Hey guys, we're going to go over the review for our test tomorrow, alright, over square root functions. Alright, so question number 1 says, how do you find the inverse of a function algebraically? It says, write out the answer in a complete sentence. Well, all you do is switch x and y, and now solve for y. Bam, that's it. That's all you have to do, okay? For this problem, all you have to do is type that out, write that out. But even when you're finding inverses of functions, all you ever have to do is switch the x and y and then solve for y again. Okay. So number 2 says, consider the function f of x equal to x squared plus 7 with the domain x is greater than or equal to 0, and its inverse, f raised to negative 1 of x is equal to the square root of x. It should say minus 7. My apologies here. I should say minus 7. Alright. What are the domain and range of f of x and of f negative 1 of x? Okay. Well, all you're going to simply do, okay, is first off, this is the original f of x is equal to x squared plus 7. Okay. So what kind of function is this? That's right. It's quadratic. Okay, and a quadratic function just looks like this. Okay, and then what does that plus 7 do to my graph? That's correct. It moves it up 7. So now my parabola is simply looking like this. It's just simply looking like that, up 7. Alright? So then, we already know the domain. They gave that part to us. X is greater than or equal to 0. So then what's the range? Well, I went up 7 and then I just keep going up after that. So my range is y is greater than or equal to 7. Alright, what about my inverse? F raised to negative 1 of x. Okay. Well, that's simply going to be, alright, they already told me what the inverse is, square root of x minus 7. Now, I just need to find the domain and range. Well, do you remember what the square root function looks like? That's right, it's just a little swoop, just kind of jumps over to the side, just like this. Okay, and then this minus 7 means I move this guy to the right 7. So now, it looks like this. So what's the domain and range? Well, the domain is clearly x is greater than or equal to 7, and the range is clearly y is greater than or equal to 0. And you might also be aware that once you know original function, you can just switch the domain and range to get the inverses domain and range as well. Alright, so let's move on to problem number 3. Alright, so problem number 3. What is the inverse of the given relation? Well, what did number 1 tell us to do? Switch x and y and solve for y. So that's the very first thing that we're going to do. Oop, I went too far. So that's the very first thing we're going to do is we're going to switch x and y, and then we're going to solve for y. So we're going to say, we're going to say x equals 7y squared minus 3. Now I need to solve for y. So I start off by adding 3 to both sides. So I get x plus 3, that's a 3, is equal to 7y squared. And then our next step, we got to get y by itself before we get rid of the square, is to divide everything by 7. So now we have x plus 3 over 7 is equal to y squared. So now I just square root both sides. And there's really no way to simplify x plus 3 over 7. So we just leave it as x plus 3 over 7 is equal to y. And there we go. We're done. That's all there is to it. Alright, problem 4. Problem 4 says, determine the transformations and identify the x and y intercept of f of x is equal to x plus 5. Okay? So, to determine the transformations, well, that should be pretty easy. That's just clearly left 5. If there's a plus 5 underneath the square root sign, that plus means left, and the 5 tells me how many. So it's just simply left 5. Alright? Then you should remember that the x-intercept just means that's where I cross the x-axis. And you know on the x-axis, y is always equal to 0. So, to find the x-intercept, you just let y be 0. So we would just say 0. So all I did was replace f of x with 0 is equal to the square root of x plus 5. Now I just got to solve for x. So I square both sides, so I get 0 squared is equal to the square root of x plus 5 squared. Alright, square root and square cancel each other out. 0 squared is just 0, so I get 0 is equal to x plus 5. So then, to finish solving, you just subtract 5 on both sides, and you get negative 5 is equal to x. Therefore, the x-intercept is the point 0, sorry, not 0, I would lead with the x, not the y, is negative 5, comma, 0. Alright, and to find the y-intercept, you do something extremely similar, okay? You just simply let x equal 0. Okay, because it's crossing the y-axis, and we know on the y-axis, x is always 0. So we get that f of x is equal to the square root of 0 plus 5. Then we know that it must be equal to the square root of 5. Can you break down the square root of 5 at all? No. So the y-intercept is just the point 0, comma, square roots of 5. Okay? Alright. Problem number 5. Find the maximum minimum over the function given the interval. Okay, the way I found that is easiest for students to do this problem is, look, they give you an interval for x. So just set yourself up a table. An x, y table. Alright? They tell you all your possible x values, 2, 3, 4, 5. I mean, yeah, the decimals exist also, but we're just going to focus on the whole numbers. 2, 3, 4, 5. Plug them in. Alright, so the function is square root of x, so if I plug in a 2, square root of 2 is just square roots of 2. So when x is 2, y is square roots of 2. Plug in a 3. Square root of 3 is just square roots of 3. Plug in a 4. Square root of 4 is 2. Plug in a 5. Square root of 5 is just square roots of 5. You can't break that down. So, which one of these is the smallest y value? Which one is the largest y value? Square root of 2 is the smallest. Square root of 5 is the largest. So this is my min. And you could check that by just looking at the calculator representation, the decimal representation. You could use your calculator to find the decimal representation. I'm not going to do that in this video because that should be very simple, but you could do that. Okay? Let's move on to problem number 6. So, problem 6. How does the graph of f of x is equal to 1/7 square root of x compare to its parent function? Okay. Oops, sorry about this. I got to bring this over real fast. Okay. So, this 1/7 is multiplying to the square root of x. So you should remember that if you have a number outside the function, multiplying to it, if it is the absolute value of it, means the positive version of it, is the 1/7 is multiplying to the square root of x. So that just simply means that it is a vertical compression. Vertical compression. I'm not going to write out the rest of the word. Just put calm. Vertical compression. All right. Number 7. What is the domain and range of y equals square root of 1/3 x? Well, this 1/3 is inside the square root multiplying to the x. So that makes it a horizontal stretch. Now, the thing is, horizontal stretches, alright, so this is what it might look like normally. A horizontal stretch just means I pull it out longer as I go across from left to right. But, let me ask you something. Did this horizontal stretch actually affect the domain and range? Like, did I move it left, right, up, or down at all? No, I did not. So the domain is still x is greater than or equal to 0. And the range is still y is greater than or equal to 0. Alright? Number 8. Number 8 says x square root of x plus 10 minus 7 is equal to negative 5. To solve this, you got to get the square root by itself first. So the very first thing we're going to do is add 7 to both sides. So we get the square root of x plus 10 is equal to, well, negative 5 plus 7 is 2. Alright, now, the next thing I want to do is get rid of the square root symbol. So I need to square both sides. So that cancels and that cancels. So I get x plus 10 is equal to 4. Alright. Now what you want to do is subtract 10 on both sides. You get x is equal to negative 6. Alright, now what you want to do real fast, you want to plug this negative 6 in and make sure it's not extraneous. It's not going to be. because we didn't change functions anywhere. We didn't do anything crazy. It was very simple. But I'm going to go ahead and just, be repetitive in plugging stuff in. So, second square root of negative 6 plus 10. And you'll notice I'm going to minus 7, and if this works, it should equal negative 5. And it does. So negative 6 is good. All right, next problem. All right, number 9. All right, number 9 says the square root of 2x plus 8 minus 6 is equal to negative 4. So step 1 is just like step 1 was for the last problem. Add 6 to both sides. So I get the square root of 2x plus 8 is equal to, well, negative 4 plus 6 is 2. Now I want to square both sides, squared and squared. So those cancel, so you get 2x plus 8 is equal to 2 squared is 4. So now you have 2x plus 8 equals 4, so you need to solve for x. So you start by getting rid of any additions or subtractions. So I subtract 8, so you get 2x is equal to 4 minus 8, which is negative 4. And then this 2x means 2 times x. So the opposite of multiplication is division. So x is equal to negative 2. Ta-da! All right, let's plug it back in, see if it works. It's going to, because once again, I didn't change functions or anything. But I just want to be repetitive. All right, so we're going to say second square root of 2 parentheses negative 2 plus 8 and minus 6. And we get negative 4, which is what we wanted. Yay! All right, number 10. All right, number 10. All right. I really encourage you now to stop the video and try to solve number 10 on your own. But first thing you're going to do is add 10. I'm going to add 10. All right. So then that gives me the square root of x plus 8 is equal to negative 4 plus 10 is 6. Now what you need to do is square both sides. Squared, squared. So I get x plus 8 is equal to 36. Then I need to subtract 8 to get x by itself. So I get x is equal to 28. Woo! And there we go. All right, so let's double check by plugging it in. I'm trying not to forget to do that. All right, so we start off with this negative 10 plus. So negative 10 plus second square root of 28. Plus 8. If this works, I will get, oh man, I forgot to, oh man, oh, there we go. Come on, keep working. I'm one too far. Second, 0, press enter, boom, I got negative 4, which is what I wanted. All right, problem number 11, which I did in class for each person, for each class. So, I'm not gonna, I'm gonna do it, but I'm gonna go kind of fast, okay, because it's a long problem. So, first off, we have 1 square root. I would like to get the square root by itself. This 5 is multiplying the square root. So step 1 is to divide both sides by this square root. 25x divided by 5 becomes 5x is equal to the square root of 10 plus 15x. All right. Next step is to get rid of the square root. So I square both sides. Okay. Square root and the square cancel each other out. 5x squared becomes 25x squared is equal to 10 plus 15x. All right, this is a quadratic equation. I have the square right here, which means I want to get this equal to 0. I want to make the whole thing equal to 0. And it's best if you keep the quadratic term positive if possible. So what we're going to do is we're just going to subtract the 15x and the 10 to take them over to the left side, thus making the right side equal to 0. So 25x squared minus 15x minus 10 is equal to 0. Now, the next thing is to notice these all have a greatest common factor. They have a greatest common factor of 5. So you get 5x squared minus 3x minus 2 is equal to 0. Okay? What is this 5 doing to the parentheses? It's multiplying. So I divide both sides by 5. So then I get 5x squared minus 3x minus 2 is equal to 0. Now I can tic-tac-toe this guy. So I'll put 5x squared right here. Put negative 2 right here. Multiply to get negative 10x squared. Okay, two numbers that multiply to be negative 10x squared, but add to be negative 3x are negative 5x and 2x. Okay? This should be a negative 3x, just to be clear, because it came from right here. Alright, 5x squared and negative 5x both have a 5x in common. 5x squared and 2x both have a common x. 5x times what is negative 5x? Negative 1. X times what is 2x? 2. So we go across, so I get the parentheses 5x plus 2 times x minus 1 is equal to 0. Now I need to solve for x. So I say 5x plus 2 equals 0, and I say x minus 1 equals 0. Subtract 2. Subtract 2. So I get 5x is equal to negative 2. Divide both sides by 5, so I get x is equal to negative 2/5. Add 1 to both sides over here to get x by itself over here. You get x equals 1. So I have two possible answers. X equals negative 2/5 and x equals positive 1. Let's use our calculator to check to see if either one's extraneous. Okay, so I'm trying to move this to where I can kind of see it a little bit better. Okay, well, we're just going to have to erase some stuff. Hopefully I already wrote everything down. Okay, so 25x. One of my possible values for x is negative 2/5. So I say 25 times negative 2 divided by 5, and I get negative 10. So now I need to plug in negative 2/5 for this x and see if it works. 5 second square root of 10 plus 15 times negative 2/5, and I get 10. Does negative 10 equal 10? Do these two sides equal when x is negative 2/5? No. Therefore, x being negative 2/5 is a bad answer. So let's check 1. Okay, so we plug in 1 on the left side, 25x, so it's going to be 25 times 1, which I know everyone already knows. I'm just putting it in the calculator so I have it there, but it's 25. And then the other one is 5 second square roots. Work. 5 second square roots of 10 plus 15 times 1. Press enter. And I get 25. 25 equals 25. Yay! So that one's a good one. Alright. Next problem. Number 12. Number 12. Alright, square root of 3v minus 12 plus 4 is equal to v. Step 1, get the square root by itself. So that gives us the square root of 3v minus 12. Alright, how would I move the 4 over? I would subtract it. It's equal to v minus 4. Okay, now I need to square both sides. So that's going to give me 3v minus 12 is equal to v minus 4 squared. Now, what does v minus 4 squared mean? It means v minus 4, times v minus 4. So I get v minus 4 times v minus 4. Okay? I multiply. First times first is v squared. First times second is negative 4v. Second times first is negative 4. Oop, forgot my v. Negative 4v. Negative 4 times negative 4 is positive 16. And I still have a 3v minus 12 over here. Alright, I have a quadratic situation. So I need to move everything to one side. So I'm going to subtract the 3v. I'm going to add the 12 so I can move this all at once. Oh, by the way, v squared, negative 4v put together is negative 8v. Alright. Plus plus 12. So I'm going to be saying here 0 equals v squared. All right, negative 8v minus 3v is negative 11v. 16 plus 12 is 28. All right, now you need to factor that through tic-tac-toe. Okay, so you put v squared here, put 18 here, 28, sorry, not 18. Get 28v squared when you multiply them. You need to add to be negative 11v. So what are two numbers that make that magic happen? Well, negative 7v and negative 4v. V squared, just v. V squared and negative 7v both have a v in common. V squared and negative 4v both have a v in common. Alright, so you get negative 7, you get negative 4. Alright, you go across, you go across. So now you have v minus 7 times v minus 4 is equal to 0. So all I did was rewrite this guy right here like this. Set each equal to 0, so you get v equals 7, v equals 4. Now you have to plug them back in and check to see if they work. Alright, so let's plug in a 7. Hopefully I already wrote everything over here down. Let me erase it so I can see my calculator. Okay, so second square root of 3 times 7 minus 12 plus 4. If this works, it should equal v. What did I plug in for v? 7. So I press enter, and I get 7, which is what I want. Okay, now let's check 4. Second square root, 3 times 4. Second square root times 4 minus 12 plus 4. And you get 4. And we plugged in 4, so that would equal v, which is what we want, because we plugged in a 4 for this v, and we want to equal v, and v we plugged in to be 4. So they both work. They are both good answers. Da-da-da! Alright. Alright, guys, shoot me an email, send me a remind if you have any questions. I hope this video was helpful.